All right, so for number 11, I'm going to stretch it out just a little bit to show you the equivalences here. So a to the 12th power, b to the 2nd power divided by a to the 3rd power, b to the 6th power. What that is 12 a's in the numerator. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. 2 b's in the numerator, 3 a's, and 6 b's in the denominator. So a divided by a is 1, so these two will cancel and give you 1. These two will cancel and give you 1. These two will cancel and give you 1. When you're done that, you look over and you have 1, 2, 3, 4, 5, 6, 7, 8, 9 a's left on the numerator. So a to the 9th is left in the numerator. And as far as b's go, 2 of the b's are going to cancel out with 2 of the b's in the denominator, but there will be 4 b's left over and they'll be in the denominator. So that's why the solution ends up being a to the 9th over b to the 4th, which is a. Now, another thing that you need to know is if you have like bases, so n to the m power divided by n to the, g power here, that's equivalent to the base in the numerator minus the denominator. So this is a to the 12th divided by a to the 3rd is equivalent to a to the 12th minus 3, which is a to the 9th. And then b to the 2nd, b to the 6th is equivalent to b to the 2nd minus 6, which is b to the negative 4th, which is equal to 1 over b to the 4th, which is why a to the 9th, because this is positive, stays in the numerator, and b to the 4th goes in the denominator if you're just doing the subtraction stuff. Okay, here's a way to check your answer, and it's a little bit, much like every other one. I'm going to take a number, 2, and I'm going to say a is equal to 2. What we don't have here is we don't have an equal sign. So if we don't have an equal sign, we can make an equal sign, and that's a great way to check our work. Take another number, 3, and that's what I'm going to store for my b values. So I'm going to do 2 store alpha a, hit enter, and then I'm going to do 3 store alpha b, hit enter, and then I'm just going to type this in, and then I'm going to type in this one and show that they're both equivalent. So I'm going to do alpha a raised to the 12th power, and then if you have one of the smarter calculators, you got to hit the right arrow to go back down to the bases. Don't really have to hit the time sign, but I like to do it anyway. Alpha b raised to the 2nd power, enter. So that's the entire numerator. So now I'm going to hit divided by, and then put parentheses around my whole denominator so I don't mess anything up here. Alpha a raised to the 3rd power, right arrow, alpha b to the 6th power, close my parentheses, and I get 256. So when I plug that stuff in, the whole original is equal to 256. 256 should also be equivalent to a to the 9th divided by b to the 4th. So alpha a raised to the 9th power, hit the right arrow, divided by alpha b raised to the 4th power. I hit enter, and that didn't work. Why didn't it work? 9, 4, a to the 9th divided by b to the 4th. Let me try with parentheses. Alpha a raised to the 9th power, close parentheses, divided by, open parentheses, b raised to the 4th power, close my parentheses, hit enter. I get the same thing. I bet you I did the numerator wrong. Okay, let me try the numerator with parentheses around everything. So parentheses alpha a to the 12th, b to the 2nd, close my parentheses, divided by, and then I'm going to open parentheses again, a to the 3rd, b to the 6th. Over, close parentheses, and oh, there we go. Okay, so I get that 6.32, which is the same thing as when I entered a to the ninth over b to the fourth. So it's definitely my fault there in the original. If you type in any of these other ones with a store button, it's just not going to work. They're not going to be equivalent. So that's a great way to check your answer and make sure you're right.